Hello everyone, welcome back to my YouTube channel again. So in this video, let's solve one super problem, that is on node analysis. You can see here it is having two super nodes, and many of you are confusing to solve these kind of problems now. So nothing is there. If the problem which looks simple, it is very complicated. At the same time, this problem is looking like complicated, but you can solve it easily. So here they ask you to find node voltages V1, V2, V3. They are only mentioned here. So V1, V2, V3. And you can easily get to know the reference node. This is your reference node, V reference. Okay. So it is having two super nodes. Sorry, three super nodes it will be having V1, V2, V3. That is V1 and V2 are one super node. V1 and V2 are super nodes. Super nodes. Similarly, V2 and V3 are supernodes. You can see this line is supernode line. It is. This is your supernode. So I'm just assuming some X or Y current which is flowing here. So I'm writing here from supernode. You'll write one equation, that is, I can write here it as V1 minus V2. You can see this supernodes. V1 minus V2 minus 25 equals to 0. Can write this as a V1 minus V2 equals 25. This is equation number 1. Similarly, you can write it here. V2 and V3 are supernodes. You can write V2 minus V3 plus pi into I equals 0. But you can see here I they are given in the problem. This is the direction of I. So whereas this I is given by V1 divided by 2. That is nothing but 0.5 times of V1. So I'll just substitute here. You can get pi into 0.5, pi into 0.5 times of V1 plus V2 minus V3 equals to 0. So pi into 0.5 is nothing but 2.5. So I can write here 2.5 into V1 plus V2 minus V3 equals to 0. This is equation number 2. So now what we have to do? So we need to follow the supernode steps. That is algebraic sum of current meeting at supernodes equals to 0. So that we need to write now. Before that, we need to give the direction of current. So now I'll give the direction of current here. So I, they are only given. This is I. They are only given in a problem. So I'm assuming that V1 to V3 some I1 is flowing. I1 is flowing and here it is entering. Similarly from V2 some I2 is flowing, and from V3 I3 which is flowing. Okay. So now algebraic sum of current meeting at supernodes equals to 0. Algebraic sum of currents meeting at supernodes equals to 0. So now we can see at V1, at node V1, I is leaving, so that minus I. Similarly, I1 is also leaving, that is minus I1. I and minus I1 at V1. Similarly, you can write at node V2, at node V2, I2 which is leaving, so that minus I2. Similarly, at node V3, so at node V3 you can observe I1 which is entering, I3 which is leaving, so that plus I1 minus I3. You need to add all these three current meeting at supernodes, that will be equals to 0. So that I am writing now minus I minus I1 minus I2 plus I1 minus I3 equals to 0. Algebraic sum of current meeting at all the supernodes equals to 0. Okay. So now this I1 and I1 will get cancelled. Minus I1 and plus I1 will get cancelled. So what you will get now? So I'll rewrite here. You will get it minus I minus I2 minus I3 equals to 0. That is nothing but I plus I2 plus I3 equals to 0. So now you write what is I, what is I1, what is I2, what is I3. So these all you need to write with the help of circuit diagram. So now I will write here. So this I is nothing but already written. So I is V1 divided by 2. That's nothing but 0.5 V1. Similarly, I want I2. You can see I2 with respect to V2 here. So I2 is given by V2 divided by 4. So 1 by 4 is nothing but 0.25. So I can write it as 0.25 V2. Similarly, this I3 is given by V3 divided by 3. Whereas 1 by 3 is nothing but 0.333. So you can write it as 0.333 V3. So this is I3, I2, I1. So substitute these equation to the equation A now. You can rewrite this equation as 0.5 V1. Similarly, plus I2 plus 0.25 V2 plus I3 plus 0.333 0.333 V3 equals 0. This is equation number 3. Now solve this equation 1, equation 2, and equation 3. With the help of calculator, we'll get the value of V1, V2, V3. Solve equation 1, 2, 3 with the help of calculator. Give me a second. So now V1 is 1 minus 1, 0, 25. 1 minus 1, 0, 25. Similarly, 2.5. V2 is 1. V3 is minus 1. Similarly equals to 0. And the third equation is 0.5 V1, 0.25 V2, 0.333 V3 equals to 0. If we solve this equation, we'll get the value of V1 as, so now the value of V1 is 7.608 volts and V2 is minus 17.391 voltage and V3 is 1.6314 voltage. These are the solutions. So you can take the screenshot. If you like this video really, kindly do subscribe and share maximum. And it is very important in a difficult condition. So this is we can solve with the help of easy methodology like this. So if you have any doubts regarding this, feel free to write in a comment box. Thank you so much. Have a nice day. Subscribe, share, like maximum. Thank you.